So a relation is a way that two or more objects are connected. So there's different ways that we can represent relations. So the first way we're going to talk about is a mapping. We're going to do a mapping. We're going to talk about graphs. And we're going to talk about domain and range and interval and set notation and lots of fun things. So the first example we're going to look at, it says make a mapping for the relation. So a mapping is just a way that we are going to show our connections between the inputs and the outputs. So the way that I'm going to write this is I'm going to write just a set of ordered pairs. Let's go maybe -2, 5, 4, 3, 9, 5, -7, -1, 6, 0, and then maybe 0, 3. Okay. So when we're doing a mapping, we're typically we're going to list out our inputs and our outputs separately, and then we're going to draw arrows to combine them, which I know when you guys were in 9th grade, so secondary math 1, those of you that were in seniors, that were our seniors, I know for sure we did this. I think if you're a junior, we also did this when you were in 9th grade. Anyways, so I'm going to list out, I'm going to say here's my x's, here's my y's. I'm going to list out my x's, but we're going to, if there's any repeats, we're only going to write it down once. So we've got a -2, 4, 9, -7, 6, and 0. So these are my inputs, and a lot of times you'll see it with like a box or an oval or something drawn around them to say, here's the inputs. And then we'll list out our outputs. So I would say we've got a 5, a 3. We don't need to write down the 5 again because we already have it written down. A -1, a 0, and then there's a 3. We don't need to write that down again. So I'm going to list out my inputs, list out my outputs. Hopefully we're doing okay there. Any questions so far? Okay. And then we're just going to draw arrows connecting things together. So we've got -2 and 5 go together. I'm going to draw an arrow saying -2. We say it maps to 5. The 4 maps to a 3. 9 also maps to the 5. So I'm going to draw an arrow mapping it to the 5. -7 maps to a -1. 6 maps to a 0. And 0 also maps to the 3. And then we could also go the other direction where I give you this and I say write the set of ordered pairs. We would start here and then go here. So on your assignment, it's going to have you go both directions. Are there any questions about how that would work? So we would remember, just a quick reminder, I know we took a summer off of doing math. X is first, Y is second, it goes alphabetical. That's how I always just remember which one's X is, which is Y is, what does it look like in the alphabet. That's how we write the numbers there. And then I would say my x and then my y. Okay. So we can also write a, we can represent a relation as a graph. So we're not actually learning how to graph lines using slope-intercept form yet. That'll come a little bit later. What we're doing, if I say graph, is say graph y equals negative x plus 3. So at this point, we don't know what a function is. We don't know how to graph a line. But we do know about inputs and outputs. So for something like this, so you could go and say, well, my y-intercept is 3, my slope is negative 1. Draw a line. But the way that we're doing it at this point in the course is we are going to just plug numbers in for x. My favorite numbers to plug in if I'm not sure what to do are negative 2 to 2. And then if I need to expand beyond that, I can, morning Kyler, come in, find a seat.
Let me get this change here.
Sure. And then I'm just going to plug those numbers in for x to give me my y. So when x equals negative 2, it's going to be negative 2 plus 3, which I can simplify that. That ends up being a 5. But I do know that the slope of this line is negative 1, which means as my x's increase by 1, my y's decrease by 1. So that's what I would get if I plugged those in. You don't need to do anything with a note card. That was from my classes yesterday. Do you need paper?
Yeah.
There's some up in that front drawer. Okay. And then at this point, I'm just going to plot the points. So it's okay, negative 2, so x equals negative 2, y is 5. X equals negative 1, y is 4. X equals 0, 3, 2, 1, 0. And then we could go and connect the dots. So let's say, let's connect the dots here. On your homework, though, it's not going to have you connect the dots. It's just going to say plot the points. So on your homework, just plot the points. But really the relation here, so y equals negative x plus 3 is all of those numbers, and technically it goes on forever in both directions. Okay. So we can represent a relation as a graph, we can do it as a mapping, we can do it as a set of ordered pairs, we can do it as an equation sometimes. Any questions so far? So a lot of this, at least especially in the beginning, is stuff that you have seen before, whether you remember it or not. This is stuff like what we're doing right here is stuff that you did in secondary math 1. Okay, anybody still need me to, I can kind of keep that there. I can write the next part down below here. So the next thing is domain. So the next thing we're going to talk about is domain and range. Does anyone remember what domain is?
It's the horizontal.
So it's our horizontal. Okay, how else could we describe? We got your horizontal axis. What would that be? You look like you had something, Evelyn, when you're saying. Are you anybody else? So it's, what was that? Sorry, a little louder.
How far up and down you can go?
So how far up and down? So that's actually going to be in your range. Domain is going to be how far side to side, which we would also say that is your inputs or your X. But it's been a summer since we've thought about math, so you're good if you don't remember this. So domain, I'm going to say it's the set of all inputs, which we usually are going to call that my X. The range is the set of all outputs, which is our Y. Okay, so there's a few different ways we can write the domain and range. If my domain, or if my relation is just a set of ordered pairs, we're just going to list out all of the numbers. If it's more than that, then we're going to have to write it a little bit different. But for this, we're going to just start simple, work our way up. So say let's state the domain and range. And I'm going to give you just a set of ordered pairs. We've got -3, 2, 0, 3, 4, 2, and -3, 0. So this is basically what we were doing with our mapping, where we listed out our inputs, listed out our outputs. But we're going to just write it a little bit differently. So your domain is your input, range is your output. So for our domain, I am just going to list them out. And we're typically, if I'm just listing out a set of numbers, we're going to use the curly brackets. And if you can't do that, it's just like a squiggle. That's fine. I feel like half my college professors, it was just like a squiggle. It didn't actually, wasn't the fancy like what you would get if you typed it. And then I'm going to list out my inputs. We have a -3, a 0, 4, and then I already have -3. So these are all of my inputs. We don't repeat values. If it's a repeated number, just write it down once. And then the range, do the same thing with the Y's. So we've got a 2, a 3, a 2, which we already have that, and a 0. Any questions on domain and range if I just give you a set of ordered pairs? Okay. Sometimes though, especially if we're looking at something on a graph, our domain and range is not something that we can just list out numbers. So we're going to have to use interval notation or what's called set notation. You guys have done a lot with interval notation, but we haven't really done set notation. So interval notation, this is where we're using square brackets or parentheses. Do you guys remember what a square bracket represents in interval notation? I do the square one. Do I include the number or do I not include it if it's square? So square, we're going to include, so we say it's closed or included. So if you see it on a number line, that'll be a closed circle. The parentheses or round brackets or however you want to call it, this is open or excluded. So interval notation, this is what you guys have been doing since secondary math 1. I taught many of you how to use interval notation in secondary math 1. So I know that you, at least if you were in my class in secondary 1, you have seen this before. We also have what's called set notation. Sometimes it's called set builder notation. So the way that we write this is we're going to use a curly bracket. We're going to write, if I'm doing a domain, we would do X. If I'm doing range, I would write Y. But I would say, we're saying, okay, let's look at X. And then we draw a vertical bar. I'm going to write it out, and then I'm going to read it out. I'm going to tell you how we read it out loud. And then I would write something like this. Got this X, and then there's this little kind of E-looking shape. It's kind of like a C, but then you draw a line in it. And then I'm going to say this R. This R stands for the real numbers. So you learned some of this notation for like the R at least, and Q and Z and different things in secondary math 2. I'm going to say, and X is greater than 3. So this is an example of what set notation could look like, or sometimes it's called set builder notation. I think the textbook calls it set builder notation, but set notation is less letters that I have to write down, so I'm going to call it set notation. The way that we read it out loud is we say, so we list out our variable. So whether it's an X or a Y. So we're saying, what variable are we dealing with? This vertical line means such that. So we're saying all X values such that. This right here, this notation is saying X is a real number. So that little E looking thing stands like means is an element of, so we're really saying X is an element of the real numbers, or we can say X is a real number and X is greater than 3. So this whole thing would be all inputs X, so all X's, all such that X is a real number and X is greater than 3. So I think the homework still has these on there. So you might see this notation on your homework. On a test, I think I just have interval notation. I would have to go back and look at the tests. But on the homework, you might see this set notation. If you look in the textbook, you might see this set notation. Okay. So if I give you a graph, so if I say, for example, I want you to find or write the domain and range. I'm actually going to look and see what your homework does before I decide if we do this in set notation and interval notation, or we just do it in set notation. So if I wanted to start with just looking at we'll start with interval notation, and then I'll decide whether we need to do set notation as well. So if I give you a graph, let's say maybe let's go part A. I'm going to draw a quadratic where my vertex is going to be at 1, 1. And then we've got a point at 2, 0, 0, 0, and then it just goes down from there. So we've got a graph look something like this. Okay. So when I write this out, let's see. So for my interval notation, so I think we will do it in interval and set. So yeah, it does look like your homework's going to make you do both. So for the interval notation, if I'm doing the domain, since I have if I just look on the x-axis, I have these arrows that are going down, which means on the left and right it's going to keep going for forever and always. So the way that we're going to say that is we're going to go from negative infinity to infinity. If I wanted to do that in set notation, we're going to do our curly brackets. I'm going to say my input is x, so it's all x's, such that x is an element of the real numbers. And because I have negative infinity to infinity, that is all I need to say. I don't need to do anything else. Any questions on the domain? And then for the range, for this one though, it goes down forever, but does it go up forever? No. So for my range, it does start at negative infinity, but it's going to stop at that 1 because we do actually have a point there. I'm going to do a square bracket. So typically, most of the time if I'm doing domain and range and it's a number that we're doing this parentheses on, we're going to have an asymptote there. Otherwise, if there's just a point there, do your square bracket. When I do this in set notation, because we're doing range, we're now going to do a y. So it's all y values such that we're doing the real numbers. The only time we would do anything else is if it wasn't continuous. The fact that everything connects, we're doing all real numbers. But we do have to specify or restrict it. So it's y is a real number, and I'm going to say y is less than or equal to 1. Okay. Questions on A? So this is where we've got an infinity somewhere. We're not always going to have an infinity. If I gave you a circle, so on your homework you're going to have one where there's a circle. So if I gave you something like this, where maybe this is actually going to move that up a little bit, make that a little bit more centered for what I want this to be. There we go. So I'm going to say maybe this is a 5, 5, negative 5, negative 5. So this is a circle with a radius of 5 centered at the origin. So if I look at the domain, it's not going to be all real numbers. It's only going between negative 5 and 5, but we're going to include the negative at 5 and 5. For the range, same kind of thing. We're going to go from between negative 5 and 5 on the y-axis, and we're going to include those. So the only times we wouldn't include it is if we've got an infinity. We don't include infinity because you can never quite reach infinity. If there's an actual open circle, so if there was something like this on the graph, or if we have an asymptote. So we're going to be looking at logarithms that have asymptotes, and we're going to looking at rational functions that have asymptotes. All things that you have learned about. And also exponential functions. So exponential functions, logarithms, and rational functions we're going to get into this year, whether it's in this class or 1050. When I write this in set notation, we're still going to do the same thing. I'm going to say, here's all my x's. X's, we're still looking at real numbers, but we have to restrict it. So I'm going to say x is a real number, and when it's between two numbers, this is where I say -5 is less than or equal to x is less than or equal to 5. So this is saying my x is between -5 and 5. Do the same thing for the range, where I'm going to say it's all numbers y, all values y, such that y is a real number and -5 is less than or equal to y is less than or equal to 5. Okay. Any questions on domain and range? So once again, this is all stuff you've seen before. I mean, you haven't maybe seen the set notation, but you've done interval notation. You've talked about what domain and range are. So everything in this section except for set notation is something that you did in secondary math 1. We're starting basic, and then we'll, as we move through the semester, we will end up doing secondary 3 topics at some point. So that is section 1.1.1. So you're going to have an assignment where it's 1.1.1, which that assignment has, I just had it open and then I closed it. So it'll be 13 questions dealing with relations, functions, mappings. We're going to finish with just functions. So we need to define what a function is. We're going to talk about one-to-one functions, which I can't remember if we explicitly defined them as one-to-one in secondary 3, and then we're going to talk about what an inverse function is, which you did do in secondary 3. So 1.1.2 is going to be getting into functions. So your 1.1.2 on your assignment is going to have 15 questions, but a lot of them are like yes or no, true or false. So it's... And then there is a 1.1.3, which I just realized I didn't. We'll get to that as well. It wasn't in my notes that I had from last year, but it's, we probably don't need to spend a lot of time on that because it's still just what is a function. Okay, so a function. Does anybody remind me anyone remember what the definition of a function is? What makes something a function? How are the inputs and outputs, or x's and y's, related to each other? And if you don't remember, that's fine. So a function, this is a type of relation where each x is mapped to exactly 1 y. So every input has exactly 1 output. So functions, each x has exactly 1 y, which on a graph, I'm going to just, technically 1.1.3 is the vertical line test, but I'm going to talk about this right now. The vertical line test. Does anyone remember what the vertical line test is? Yes.
If you pass a vertical line to the graph and it touches like more than 2 points on one axis, then it doesn't pass the line test. And it has one x function has multiple y outputs.
Yeah, exactly. So in order to, I'm trying to think how to phrase this. So if a vertical line crosses a graph multiple times, it is not a function. Or you could also say that a vertical line crosses the graph exactly one time. So sometimes it's easier to think about what makes it not a function as opposed to what makes it a function. So in there on your assignment, there is an entire section devoted to the vertical line test and then the horizontal line test, which we're going to talk about in just a second. But I figured we would just talk about it real quick right now. I don't think we necessarily need to do any examples over it, but just know, don't cross the graph more than once. So function, it's a relation where each x is mapped to exactly one y. So we can't have any duplicate x's. And then vertical line test, this is a way to easily see on a graph. If the vertical line crosses multiple times, it's not a function. We also have what's called a one-to-one function. Which I can't remember if we defined this in secondary 3, but we did kind of talk about it in secondary 3. So a one-to-one function, this is a type of function. So the fact that I'm saying it's a function, that means that each input has exactly one output. But we're going to restrict it a little bit more. We're going to say it's a function where each y value is mapped. So each y is mapped from or by exactly one x. So we're taking it where it has to go both directions. So not only does each x have to have exactly one y, but each y has to have exactly one x. So to see if it's a function, it has to pass the vertical line test. In order for it to be a one-to-one function, we have the horizontal line test. So this says that if a horizontal line crosses the graph multiple times, it's not 1, 2, 1. So it's just the same kind of thing as the horizontal or the vertical line test. We're just now looking at horizontal lines. However, even if something passes the horizontal line test and it's not a function, it is not a one-to-one function. So everything with one-to-one has to fit all of the function requirements. So if it's not a function at all, it is not one-to-one. Okay. Questions on that? Okay. So then the last definition that we're doing for today, I know there's a lot of definitions, is an inverse function. So an inverse function, this is a function or a one-to-one function. And does anybody remember from secondary 3 what it meant if we were doing inverses? I know this was like unit 1 last year. But what did we do with our x's and y's when we found our inverses? We switched them. So it's a one-to-one function where that, I was trying to see, I want to shorten the definition. That switches the input and output. Or we could say x and y. So it is important that we are saying that it is a one-to-one function, because otherwise you can find an inverse, but the inverse won't be a function. So on your assignment, it'll say something like, does this have an inverse? And then if so, what is the inverse? So if I just give you a set of ordered pairs, so for a set of ordered pairs, just switch x and y. So if I gave you something like 1, 2, 3, 4, 5, 6, and I said find the inverse, we're just going to take my x and y and switch them. We're going to have 2, 1, 4, 3, and 6, 5. So on the assignment for when we're dealing with inverses, so with if we're looking at a graph, it'll say, is this a function? Yes or no. So does it pass the vertical line test? And then it'll say, if it is a function, does it have an inverse? Does it pass the horizontal line test? And then so that's 1.1.3, 1.1.2, it's going to say something like, if a one-to-one function has this domain and this range, find the domain and range of the inverse. So I'm going to make a note here that we want to also switch. We could also say domain and range at this point. So we're going to switch the domain and range. State the inverse from that way. Okay. And then one last thing that we're going to get to is, so this last example is I'm going to say something like g is a function that says add 6 to any real number. So the first thing we're going to do is write that in function notation. So this is our f of x, g of x, h of x, whatever. So I would say g of x equals something. So if x is my input, what would the rest of this equation be? We have g of x equals something. How would I finish writing this? If my rule is add 6 to any real number, we're just going to add 6. So function notation, we're just saying g of x equals x plus 6. I could say something like 1 is in the domain of f of x. What does it map to? This is basically asking, well, what is f of, or sorry, I wrote f of x. That should be g of x. I was looking at an example on my computer, which was f. We want to do the one with the g. So what does it map to? This is just saying g of 1 equals what? It's equal to 1 plus 6, which is 7. Questions on that? And then the last thing, this could be phrased a couple of different ways. Actually, we're going to do 2 more. This could say something like, I could either say something like, negative 6 is in the range of G. What mapped to it? Or I could also say something like, I could say things where we're looking at, I could rewrite it and say negative 6 is in the domain of G inverse. What does it map to in? Anyway, so I could say something like this. This is the exact same question written two different ways. Because remember, we switched domain and range. So if I say negative 6 is in the range of G, what number mapped to it? Or I could say negative 6 is in the domain of G inverse. What does it map to? It's the exact same question, writing it two different ways. You're going to see it written both ways. So really what I'm saying is we have negative 6 is my output in G of x equals x plus 6, and then just solve that equation. If negative 6 is equal to x plus 6, what is x equal to?
Negative 12.
Negative 12. So either have G inverse of negative 12 equals negative 6, or G of negative 12 equals negative 6. And then the last thing that we're going to do is I'm going to say write the equation of the inverse. So it's this G inverse of x. That's that notation. Which, if you recall, this is where we just switch x and y, solve for y. So I'd say x equals y plus 6. Subtract the set 6, which means x minus 6 equals y, which means my inverse G inverse of x equals x minus 6. Okay. Any questions on that? I know it's kind of a lot, but none of that should be anything that is too terribly difficult.